Hello, this is Shivanand Thorat. In this fourth episode of the series, Data Analysis using Excel, we will see how to test normality using Kolmogorov-Smirnov test, also called as KS test, and Skewness and Kurtosis values in Microsoft Excel. Normality refers to a specific statistical distribution called a normal distribution, or sometimes the Gaussian distribution or bell-shaped curve. The normal distribution is a symmetrical continuous distribution defined by the mean and standard deviation of the data. Now, the normality test is basically a hypothesis test. The null hypothesis, we can call it as HO, is that the data is not different from normal. The alternate hypothesis, we can call it as HA, is that the data is different from normal. We want to make decision about whether to reject or not to reject the null hypothesis based on p-value. So technically we want p-value to be greater than 0.05, that is, the test statistics should be non-significant in order to call the data to be normally distributed. To test normality, I have this hypothetical data of achievement motivation variable with 30 respondents. To compute Kolmogorov-Smirnov normality test statistic, we need 6 different values shown in the header row. We will compute these variables step by step. The first thing we need to do is to arrange this data in ascending order. For that, select entire data by using Ctrl A. Go to the sort and filter option under Home tab. Select custom sort. Check on My Data Has Headers option and sort data by achievement motivation. Order should be smallest to largest, so you can set order here. Click OK. Now you can see that achievement motivation variable scores are arranged in ascending order. The next thing that we need is sample size. Now in this dataset, I have 30 respondents, so I will write sample size as 30. I'll double click to autofill it till the last respondent, or you can drag it down to autofill. To compute mean, put equal to sign in the cell and type average. Double click on average to activate it. Then select the entire column of achievement motivation and press enter. Now copy and paste it as a value by using Ctrl C and Ctrl V. Click on Control option, select on paste as values. Now double click or drag down to autofill. To compute standard deviation, press equal to sign and type stdev.s. Double click to activate the formula. This function estimates the standard deviation based on a sample. To compute standard deviation for sample, select the entire test variable. Hit enter. Copy and paste the standard deviation value in the same cell. Click on Control option and paste it as value. Now drag or double click to autofill. The next variable we need is rank. In rank variable, we need count from 1 through 30 as we already have our data in ascending order. So I will type 1, 2, 3, select all and double click to autofill or drag down to autofill. In variable rank minus 1 divided by n, that is sample size, we need to subtract 1 from rank variable and divide that difference by sample size. So hit equal to, press brackets, rank minus 1 complete bracket divided by sample size, that is 30. Hit enter. Double click or drag to autofill. In the next variable, we need normal distribution function. Put equal to sign. Type norm dot dist. Double click to activate this function. Now this function has four arguments. The first one is x, that is raw score. The second one is mean. Third one is standard deviation, and the last one is cumulative. So for the first one, that is x, that is a raw score, we will select the first score of achievement motivation, comma, the second argument is mean, that is in column C, comma, the third argument is standard deviation, that is in column D, comma, the last argument is cumulative, and it has two choices of true or false. True means cumulative distribution function, false means probability mass function. So in this case we want true, so we will double click on true, complete the bracket and hit enter. You can drag down or double click to autofill. And the last variable we need to compute is difference, that is normal distribution minus rank minus 1 divided by n, that is column G minus column F. Press equal to sign, select value in column G minus select value in column F, hit enter, double click or drag to autofill. Now the Kolmogorov-Smirnov statistic is nothing but the maximum value of difference. To find that, we will use maximum function. So ks equals to max max function, that is maximum function. Double click to activate and select difference column. Hit enter. This value is the maximum difference value, that is the ks statistics. So the ks statistic value for this dataset is 0.11964. Now we need critical values table for ks test that I have included in the sheet 2. I have also provided this table in the description of this video. Now our sample size is 30 and we want to check critical value at 0.05 level of significance. So alpha being 0.05, that is we have to check column D, and sample size is 30, so we have to check row 32. And we can see that the critical value for this particular dataset is 0.242. Our case statistic is 0.11964, which is less than the critical value. It means that the null hypothesis is accepted, stating that there is no difference between the two distributions, that is, our distribution and the normal distribution. This means that our variable is normally distributed. Just to cross-check this case statistic value, let us use SPSS. I have already copied this data to SPSS. To check normality, go to Analyze, then to Descriptive Statistics, and select Explore option. This dialog box will pop up. Move Achievement Motivation variable to the dependent list. Under Plots, check on Normality Plots with Tests option. You can set box plots to none, and you can check histogram if you want. Click Continue and click OK. You will get the output. In the tests of normality table, you will get KS test statistic along with its significance value. If you double click on the value, you will see the exact value of KS statistics which matches the value we have calculated. But KS test is sensitive and most parametric tests are robust for the normality assumption to some extent. You can also use less sensitive measure of normality based on skewness and kurtosis values. You can compute these values using descriptive statistics option in the Data Analysis ToolPak available under the Data tab. To check skewness and kurtosis values, go to Data tab, select Data Analysis option available under the Data tab. If this option doesn't show in your Microsoft Excel, please watch first episode in this series. I have added that in the I button as well as in the description of this video. Click on Data Analysis. This dialog box will pop up. Select Descriptive Statistics option. Click OK. Now this dialog box is asking you input range. Input range is a test variable value. So we will select column A. Our data is grouped by columns, so we will keep it as it is, checked on columns. Check this option, labels in the first row. Now in the output options, select output range as a blank cell. Check summary statistics option. Click OK. You can adjust column widths. Here you get skewness and kurtosis values. For a normal distribution assumption, skewness should be from -1 to +1 and kurtosis value should be between -2 to +2. In this case, both skewness and kurtosis values are within the ballpark, indicating that the achievement motivation variable is normally distributed. I hope you find this screencast helpful. Like and share this video. Check video description for references. As usual, if you have got any questions or anything else that you would like to see, please leave a comment. And if you want to be notified of any of the tutorials, then just click subscribe and a little bell next to it. Thanks a lot for watching. This is Shivanand Thorat and I will catch you in the next one.